Problem number 4 on midterm 1 asked us to consider a rock climber of mass m, 60 kilograms, who is ascending a vertical wall and stops her rest by leaning back on her rope, as seen in the diagram. The rope has some unknown tension and it makes an angle of 31 degrees with the vertical. As the climber rests, the wall exerts a force of an unknown magnitude, and this force points at the angle of 15 degrees above the horizontal. This question has 3 parts. In part A, it asks us to find the magnitude of the tension in the rope in order to keep the climber to remain unmoved. It also asks us for the magnitude of the force of the wall on the climber, and then asks us for the coefficient of static friction between the wall and the climber.
So part A asks us to find the magnitude of the force of tension. So for this we know it's a static equilibrium problem. So the V initial and V final are both equal to 0. So there's no change in velocity. Therefore, there's no change in momentum, and F net is 0. So we know that the force of the tension plus the force of the wall plus the force of the earth are all equal to 0. So we can split the forces into x and y components. And that makes it easier when you draw a free body diagram. So we know we need to find the magnitude of the force of tension. So first let's find the sum of the forces in the x direction. That is equal to the magnitude of the force of the wall times cosine of 15 plus the magnitude of the force of tension times sine of 31. Now to find the sum of the forces in the y is equal to negative mg, which is the force of earth, plus the force of the wall times sine of 15 plus the force of tension times cosine of 31. Let's set the force of tension, or the force of the wall, in terms of force of tension. So from the first equation we get the magnitude of the force of the wall is equal to negative the magnitude of the force of the tension, sine of 31, divided by cosine of 15. So now let's plug this into our forces in the y equation. So we have mg is equal to the negative force of the wall, sine 15, minus the force of tension, cosine 31. We know that the force of the wall is equal to this, so we can just change this to a force of tension sine of 31 sine of 15 over cosine of 15. Then, when you solve for force of tension, you get 591 newtons as the force of tension. Part B of the problem asks us to find the magnitude of the force of the wall. So again, we know that the sum of the forces in the x direction is equal to 0, which is equal to the magnitude of the force of tension times sine of 31 minus the magnitude of the force of the wall times cosine of 31. To isolate the force of the wall, we get force of the wall magnitude is equal to the force of tension, the magnitude of that, times sine of 31 over cosine of 15. So we remember that the force of tension was equal to 591 newtons from the previous part of the problem. Sine of 31 over cosine of 50 is equal to 0.533. So when you multiply those together, you get a magnitude of 315 newtons. So part C asks us to find the coefficient of static friction between the climber and the wall. So we know that the friction is less than or equal to the coefficient of static friction times the normal force. So the normal force is our x component of our magnitude of the force of the wall. So we find that by multiplying the magnitude of the force of the wall times cosine of 15. Our friction, magnitude of friction is equal to the magnitude of the wall, the force of the wall, times the sine of 15, because this is our x component of the wall, since the wall is our normal force. So to find the coefficient of friction, you know that coefficient of friction times the magnitude of F wall, cosine of 15, is equal to the friction, which is F wall, sine of 15. When you divide both sides, you get the coefficient of static friction is equal to, the two F walls cancel out, so you just get sine of 15 over cosine of 15, which is equal to the tangent of 15, which is equal to 0.268, and it has no units.